Point six, molecular compounds. Have here that a molecule is a group of two or more atoms chemically bonded together. Diatomic molecules are molecules consisting of two atoms. Now, typically, they will be the same element from what I've seen. I mean, not typically, but it's important to know that a lot of diatomic elements are the same elements, such as oxygen gas over here and hydrogen gas. And the naturally occurring diatomic elements are nitrogen gas, oxygen gas, argon gas, chlorine gas, bromine gas, and fluorine gas. This is important to know. Later on, a lot of questions will come up using these, but to memorize this, I would use the acronym HAVE NO FEAR of Ice Cold Beer. That's how I was taught it. But um, yeah, these are the naturally occurring atomic elements. So let's delete this. A molecular compound is a compound composed of molecules formed from two or more different nonmetals. It's important to note that it can't be a metal and a nonmetal because that forms a different kind of compound, an ionic compound, which we'll learn about in the next lesson. That's because the nonmetal will just rip the electron off the metal, and they'll be bonded because there's a negative and positive charge. But all we need to know is that a molecular compound is just a compound composed of molecules, which the molecules are formed by two or more different nonmetals. A chemical formula uses atomic symbols and numeric subscripts to indicate the type and number of atoms in a substance. I'll get to that later, where I'm just going to show you a little bit of stoichiometry and how a chemical formula is used. A molecular formula indicates the exact number of atoms of each element in a molecule, such as hydrogen peroxide over here. An empirical formula shows the simplest whole number ratio of atoms in a compound. So note here that H2O2, you can divide the subscripts by 2, which gets you HO. So this would be the empirical formula, this would be the molecular formula. Structural formula is a formula that shows the arrangement of atoms and the bonds between them. The ball and stick model is a 3D model showing atoms as balls and bonds as sticks, useful for visualizing angles and structures. And the space filling model just shows the relative sizes of atoms and how they occupy space in the molecule. So first, let's focus on the chemical formula. And I'll use a very simple combustion reaction, which you guys will learn about later. In chemistry, this is a really important type, and we're just gonna have some other thing here. We'll just use X. So it's important to note that the small numbers that are beneath the elements or to the right of the elements indicate how many of the atom is in each molecule. So it technically gives the molecule its identity. So O2 is 2 oxygen molecules that are bonded together. So picture these as oxygens. This carbon dioxide is just going to be 2 carbon molecules. One carbon molecule, one carbon dioxide molecule with 1 carbon and 2 oxygens. So these just denote how much or how much of each atom is present within, and if there's nothing there, you can assume it's 1. So water, it's just going to be H, 2O, 2 hydrogens, 1 oxygen. And the subscripts will indicate how many of each you have, or how many of each you need for the reaction to occur. So that means you'll need 2 carbon dioxide molecules, or 2 will be made, because the reaction is making carbon dioxide. So that's all that means. For now, you don't really have to know this for the most part now, but stoichiometry gets really it's one of the most important things in chemistry, especially later on. So And now we just go over different models. So we have the structural model, which just shows the arrangement of atoms and the bonds between them. I believe this is referring to Lewis structures. And so if we have something like fluorine, we have one bond between them with all the electrons surrounding it. That's what it is. I don't think you have to learn how to do this until way later, so this is not important for now. The ball and stick model is just a way that textbooks will express molecules, and it's not just textbooks, obviously, scientists use this. So let's imagine the molecule H2O because it's everyone's favorite. Um, it's just going to be H2O. This is going to be oxygen, this is going to be hydrogen, this is going to be another hydrogen, and they'll just make the molecule like this. This is the bond sigma. And the last model is the space filling model, which shows the relative size of atoms. Instead of using water, actually, let's just use water because it's everyone's favorite, of course. We have hydrogen, and then it's bonded to an oxygen. So notice how the oxygen is slightly bigger, well, not slightly, a lot bigger than the hydrogen atoms over here. That's because hydrogen is one proton, and it's not as big as oxygen, pretty much. And that is another way molecules will be expressed.